Hello everyone, I'm Shreya and I welcome you back in this machine learning tutorial series. So, in the previous video, we saw that what is logistic regression and how it is different from linear regression, and we also saw the sigmoid curve, or we can say the sigma curve that we have in the logistic regression. And we also talk about the dependent variable nature, that is it should be categorical in nature, and we also went through the sigmoid function that we used in the logistic regression, that is f of x is equal to 1 upon 1 plus e to the power minus x. Now in this video I'm going to implement logistic regression with the help of Jupyter notebook. So so I have created a one file with the name of logistic regression, and I have imported these libraries. As you already know that uh, we have sklearn with the help of which we can implement logistic regression. So with that I have included the logistic regression, and matplot basically helps in plotting and splitting and the splitting also. Splitting basically is the part of sklearn, but with the help of matplot we can have like chart plot, or different types of plots that and we can have also different types of functions like to get the different like top 5 elements, and so functions, as we have discussed in the previous sections of the linear regressions also. And in this section, like in this implementation, I'm going to make a new data set with the help of make classification function of the sklearn data sets. And I have made X and Y, where the which have a classification have a samples of 100, and features 1, classes 2, and clusters per cycle is 1. And these are the information of the dataset that I have made. Now I tried to implement it using a scatter, and this is the scatter plot of the logistic regression for on the dataset that we have created. So so this data set, as we can see, most of the elements are in the like most of the elements from the zero, like below zero, are inclined horizontally below, or in equal to the range of zero point 0, and others like who are above 0, most of them are above 0, as is inclined at 1.0. Now, I have used train test split to split the datasets into training and test datasets. And after that, I have created a logistic regression instances, or we can say the object, and we have performed the logistic regression in here. And after that, we have to show the like coefficient and intercept that we have in the logistic regression as well. And after that, we have to like predict it, and I tried to store it in y predict. After that, I created a confusion matrix with the help of like y test, and that is y test is the like the test that is containing the data sets that containing like it is a data set which is containing the those data which can be helpful in testing the our model. And after that, we have the predicted one also, and according to that we have created the confusion matrix. As you can see, it is a 2 by 2 matrix, where the first like first column and first row have the value 12, and for second column and first row have value 1, and first column and second row have value 4, and the second column and second row have the value 8. So what you are getting from the confusion matrix maybe will be maybe unclear now, because you don't know about the confusion matrix up till now. Like here it will be like clear to you, as we have already done in the previous sections also. So in this section I'm also going to talk about confusion matrix. So confusion matrix is one of the way in which we can show the results, like I'm talking like taking the example of as here only. The confusion metrics have a basic structure, that is this side it will contain the predicted values, and it shows the predicted values, and this side it shows the actual value, that is what is the actual value it has. Okay, and the first column have the false value as the predicted one, and the second have true value. So what is the meaning of, like I'm talking about this, that is a true negative. True negative means that the actual value that we have is false and the predicted one is also false, which means that we have found the true value. And what is the true value nature? It is negative. That is, we have found the false result as false, and this is what for us it is true result. So that's why it is true negative, and this value must be high for a data set or for the logistic regression, for better implementation. Okay, and talking about like false positive. False positive means that we have the false as the result, but it is predicted as true, which is obviously false, right? So this value must be less. Talking about false negative. False negative means that we have the actual value as true, but we have predicted it as false. But that is not true, right? We are not getting the correct result in this scenario. So this value must also be less. Talking about true positive. True positive means that those values which are actually true and we are getting or we are predicting it as true as well. In that case, it is true positive, and this value must be greater than, or like false positive and false negative. So what is the result that we are getting? The result that we are getting is 12, 1, 4, 8. 12, 1, 4, 8. As you can see, we have the larger true value, true negative value, and true positive values, and false positive value is very less, which is good. That is, which is closer to the ideal result, and false negative is also less. So we can say that we have implemented logistic regression with true results, and in the next video, we will see the different topic, and up till now we have covered linear regression and logistic regression. So you can implement different different on different data sets, linear regression and logistic regression, and you can understand the different terms and how we can represent it, and what are the terms related to the representation as well. So in this video, that's all. Hope you liked it and enjoyed it. Thank you. Stay blessed.